Could the era of massive AI clusters be over? What if the supercomputers of tomorrow sit on designers' desks instead of filling data centers? And why did Jensen Huang personally deliver NVIDIA's new DGX Spark to Elon Musk at SpaceX? In October 2025, a symbolic gesture unfolded: a small AI powerhouse handed over beside the world's most powerful rockets. Let's unpack why that matters and what this tiny machine could mean for the future of AI. Oh, and wherever you are, subscribe now if you want insider insights into AI, hardware breakthroughs, and the shifting power in tech. You're watching StockScope AI, your global lens into AI, innovation, and tech revolutions. Let's dive in. On October 13th to 14th, NVIDIA shipped its first DGX Spark units, and Jensen Huang personally delivered one to Elon Musk at SpaceX's Starbase facility. Huang described it as delivering the smallest supercomputer next to the biggest rocket. This act echoed a moment from 2016, when Huang delivered the original DGX-1 to OpenAI, a moment that later fueled the AI revolution. The delivery symbolizes a new narrative. Supercomputing is no longer confined to labs. It's entering the hands of individual developers. DGX Spark is built around the GB10 Grace Blackwell superchip, integrating CPU, GPU, and memory in a compact form. Key specs include 1 petaflop of AI compute, which is up to 1,000 TOPS at FP4 precision, 128 gigabytes of unified system memory CPU and GPU coherent, storage up to 4 terabytes NVMe SSD optional, and compact dimensions of about 150 mm by 150 mm by 50.5 mm. The weight is around 1.2 kilograms. It supports models up to 200 billion parameters for inference and fine-tuning up to about 70 billion parameters locally. Networking includes ConnectX-7, NVLink C2C, enabling clustering of DGX Sparks to handle larger models. Pre-orders suggest a launch price of $3,999 US. Until now, training or inference on large models demanded cloud or cluster resources, with latency, cost, and security trade-offs. DGX Spark brings data center class performance to the desktop, enabling developers to prototype, test, and iterate locally. For privacy-sensitive workloads, having compute locally really minimizes data exposure to external servers. It democratizes AI labs. Small studios and universities no longer need massive infrastructure to experiment. With DGX Spark, you can run local AI agents or autonomous systems that interact directly with your environment. You can fine-tune or generate images using vision models like Flux 1 or similar architectures. It's possible to serve chatbots or perform large language model inference, running models like Qwen 3 or others locally, all with impressively low latency. For education and research, universities and startup labs can accelerate experiments, without those massive cloud bills. And in robotics or edge AI, you can embed Spark's power right near the edge. Think robotics testbeds or IoT nodes. The act of delivering to Elon Musk at SpaceX connects AI computing with space, future technology, and that kind of visionary branding. It really shows that NVIDIA isn't just building hardware, they're shaping a narrative where, honestly, every developer could have access to supercomputer power. It sends a clear signal to competitors like AMD and Intel. The battleground is shifting toward compact, high-efficiency systems. This move might even accelerate new AI frameworks, optimized for smaller devices, and shift power away from those big, centralized cloud monopolies. Now let's be real, price versus capability is still a big question. $3,999 is, relatively affordable for developers, but it's still high for a lot of folks. There are hardware limits too. 128 gigabytes of memory sets some bounds. Clustering can help, but honestly, it just adds complexity. There are also thermal and power constraints, and you have to think about long-term reliability in such a compact form factor. Ecosystem support is another hurdle. Software libraries and frameworks need to be fully optimized. And yeah, competing cloud and edge AI solutions remain pretty attractive at scale. So, did Huang just usher in a new era where supercomputers actually live on your desk? Or is DGX Spark more of a beacon, a hint of what's possible, while real performance still lives up in the clouds? Tell me in the comments, would you use one? What would you build with that kind of power? And hey, don't forget to like, subscribe, and hit the bell to stay on top of AI hardware advances. This is StockScope AI. See you in the next video.